Good morning, all. Myself, Sudharani. Today, I came up with one more topic in information retrieval system. Today, we are going to see types of information retrieval system. Types of information retrieval system. We are having different types of information retrieval system like web retrieval and mining, semantic web, XML information retrieval, recommended systems experts locators, knowledge management systems, decision support systems, GIS. Let's see one after another. GIS stands for Geographic Information System. GIS, any computer-based manipulations, analysis, or presentation of geographical data. Common data for land cover applications includes roads, lakes and rivers, land use like forestry, mining, residential, neighboring, etc. GIS now has a wide variety of applications. The key to all data in a GIS is that it is georeference, meaning it has a known location. All information in a GIS has an attribute and a location. So attribute means what it is, and location is where it is. GIS is ultimately a problem-solving, decision-making tool. In the GIS database structures, a GIS database is comprised of layers and attributes. Examples for layer forest cover, attributes tree species, overstory, height, M, canopy closure, undisturbed species, age. Information in GIS is stored in 4 ways depending on the feature. First, points like hospitals, oil wells, phone booths. Second one, lines like roads, streams or rivers, railroads. Next one, polygon like crop fields, forest stands, and last is the pixels for raster-based GIS. If you see here, we can see GIS data structures, points, polygons, lines. See here, these are the different layers like roads, and second layer water, next third layer vegetation, next buildings. This is the polygon, line, and the points. So we seen here we can see points, hospitals or wells or phone booths, lines, roads, streams, rivers, railroads, polygon and pixels. See here again. So these are the points, lines, polygons. We can also see vector GIS, raster GIS. We can have two different types, vector GIS and the raster GIS. In the raster GIS, we can divide into cells. Again, roads, water, vegetation, building. GIS science, geographic information science. Geographic information science is only one discipline of GIS sciences, the analysis, problem solving, decision making, and modeling. How do we get the data into a GIS? This is where GIS science becomes important. Cartography, the art and science of map marking. Geodesy, the science and accurate measure of the earth. Surveying, the science and accurate measurement of natural and man-made features on the earth. Photogrammetry, the science of measurement from photographs and images. Let's see again. First one, we used to get the GIS sciences. It is useful in some of the fields like cartography, the art and science of map making. So in the map making, GIS sciences are very useful. Geodesy, the science and accurate measurements of the earth. So if you see in nowadays, this all the GI sciences are very, very important. And in the GI sciences, whatever the information retrieval system we are using, that comes under GIS. Next, surveying, the science and accurate measurement of natural and man-made features on the earth. So geodesy is natural measurement of the earth, where surveying is the science and accurate measurement of natural and man-made features on the earth. Photogrammetry, the science of measurement from photographs and images. GPS, the accurate location of positional information. Laser altimetry, the accurate measurement of height from the air, like trees, buildings, etc. Remote sensing, the science of Earth, observations from space. Image processing, the science of analyzing imagery to gain useful information. Areas of practical application, where this geoscience, where this GI science is applicable. What are the areas of practical application? Natural resources applications, natural resource inventories, FRI, water quality, level, flow management, environmental assessment and EIA, V-shade, V-scape analysis, groundwater modeling, hydrology analysis, wildlife habitat analysis, migration routes, etc. Areas of practical applications, land applications, zoning, tracking urban spurs, land acquisition, land ownership, facilities, utilities management, locating underground cables and pipes, municipal telephone systems, tracking energy use, network analysis, web network analysis and mapping, least cost path analysis, ambulance and other services, address matching, vehicle scheduling and routing, location analysis, site selection, GA subspaces, subsystems, data processing subsystem, data acquisition from maps, images or fields, field surveys, data input. Data must be input from source material to the digital database. Data storage, how often is it used? How should it be updated? Is it confidential? Next, data analysis subsystem. Retrieval and analysis may be simple responses to queries or complex statistical analysis of large sets of data. Information output have to display the results or as maps or tables, or will the information be fed into some other digital system? So next, information use subsystem. Users may be researchers, planners, managers, interaction needed between GIS groups and users to plan analytical procedures and data structures. Management subsystem, organizational role. GIS section is for often organized as a separate unit within a resource management agency offering spatial data set, database and analysis services. Error management, GIS management staff. So this is introduction about the types of information retrieval system. Now let us move to the next topic, indexing, which is a very interesting topic. Let's move to next topic, indexing. An index is a table containing a list of keys associated with the reference fields pointing to the record where the information referred by the key can be found. An index lets you impose order on a file without rearranging the file. A simple index is simple an array, pairs. You can have different indexes for the same data. Multiple access paths. Indexing gives us keyed access to the variable length record files. Indexing plays a crucial role in information retrieval systems by enabling efficient search and retrieval of relevant documents from a large corpus of data. Indexing in an information retrieval system is the process of organizing and structuring documents or data in a way that facilitate efficient and effective search and retrieval. It involves creating an index, which is essentially a data structure that maps contents to specific term, phrases, or metadata associated with the content. Indexing typically focus on following tokenization. The first step is breaking down the content into smaller units, such as words, phrases. This process is called tokenization. For example, the sentence here we are taking some sentence like the quick. This is a sentence. This is a sentence. The quick brown fox jump over the lazy dog. This is a sentence. And now in the tokenization procedure, the sentence has to be divided into individual words. Let us see here. The sentence is divided into the words like the quick brown fox jumps over the lazy dog. The sentence is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 words. So this is dividing the sentence into words is called as a tokenization. Next, normalization. Another process, another step of indexing is first one is tokenization. Second one is normalization. In the normalization involves standardizing tokens to a common format to improve consistency. Normalization involves standardizing tokens to a common format to improve consistency. This can include converting all text to lower cases, removing punctuations, and handling variations of words. These are also called as stemming or lemmatization. So in NLP, stemming and lemmatization both together called as a normalization. So if you consider the NLP, we used to take tokenization and normalization two steps, where in the information retrieval system, we used to take the steps as text pre-processing, like conversion lowercase, and next removing punctuations, removing stop words, stemming, lemmatization, tokenization, all this comes under the steps of text pre-processing. Stop word removal, as we discussed now, stop word removal. In the stop word removal, some words known as stop words like and, is, that, this, for, what, where, sorry, for, there, them, as, such kind of words are called as a stop words. And these stop words may not be useful for indexing because they appear frequently and do not carry significant meaning. These words are often removed from the index string to reduce its size and improve efficiency. Index creation. So after stop word removal, next step is index creation. Once the content has been tokenized and normalized, an index is created. This index typically consists of data structures such as an inverted index or a term document matrix that maps terms to the documents in which they appear. Each term is associated with a list of document identifiers for pointers to the locations where the terms occurs in the documents. Index storage. The index is stored in memory or on disk, depending on the size of the data sets and the requirements of the retrieval system. For large-scale systems, indexes are often stored on disk and located into memory as needed to support each query. Query processing, where a user submits a search query, the user proceeds by the retrieval system. This may involve tokenizing and normalizing the query terms, then looking up those terms in the index to identify relevant document. Query processing, when a user submits a search query. The query is processed by the retrieval system. This may involve tokenization and normalization the query. For example, let's take one live example. Let's take one live example. Okay, here I am giving one query to my search engine like what is the most important feature of AI. Okay, so this is the query which I am going to give the search engine. Now, this is the query. This is the query. How this query is how the search engine is going to process this query. That is the thing we are checking for now for query processing. See, if we are giving this query, this is the system. The system is considered complete query as one sentence. And now this one, now we discussed that first we have to do the tokenization, then we have to do the normalization before the query processing. So for this sentence, the first thing is tokenization. Means what is the most important feature of AI? So this query, it won't take, the search engine never takes it as a complete sentence, but it will make the tokenization, means dividing the words. So what words it is going to divide? Let's see. Let's see here. Right. So here, if you see, so what is the sentence? Let's do the text pre-processing. What is the most important important feature of AI, right? So this is the query which I am going to give for my search engine. Now let us see how it is going to process according to indexing. According to indexing, the first thing it is going to do is tokenization, which is divided words. Now let's see how it is going to tokenize. What is the important, what is the most important feature of AI? Right. So this is a tokenization. The first step is completed. We divided the complete sentence into the different words, and the tokenization is completed. And next, stemming and lemmatization. So stemming and normalization, that is. So before normalization, now let us do the stop word removal. Now we have to remove the stop word removal. So here, what are the stop word in the sentence? What are the stop words? We have to remove the stop words is, the, of. These are the, so what are the stop words? Second step we are doing is stop words removal, stop word removal. So what are the stop word we identify here in the sentence is the, of. These are the stop words. So after the stop word removal, we are getting the what most important features of AI. So stop words we got as is, the, of, and now what are the keywords? Keywords I generated is what? Most important and AI. These are the words which we got after removal of stop words, and from this word we have to check for the keywords which are going to map up with the indexing. So here with this I am identifying the keywords like most important AI. These are my keywords which I am going to identify for this query. Right. So like this, many search engines are going to process the query, whatever the query we are going to give. The search engines are going to process in this way, like first tokenization, next stop word removal, next keyword identification, and next indexing. Now come back again to the slides. So query processing. When a user submits a search query, the query is processed by the retrieval system. This may involve tokenizing and normalization the query terms, then looking up those terms. Indexing is identify relevant documents. So now, so how it is going to search and what are the relevant documents it got? See, what are the relevant search we got? Important AI, most, and features. Sorry, here I forgot. Another one is features. Right. So the most important things we got for searching is what? Most important feature AI. So these keywords are taken and indexing by using the data structures, and then the searching will be made easy for search engines. Next, ranking. Once the relevant document have been identified, they may be ranked based on the relevance of the ranking. Various ranking algorithms such as TF, IDF, term frequency, reverse document frequency, or BM25 can be used to determine relevance documents to the query. So another one is ranking system also there. Let's take another example and check what is a ranking system. We'll take one live example and tell you what is a ranking system. The cat sat on the wall. This is first sentence. This is the first sentence. The cat sat on the wall. The wall is full of white color. The wall is full of white color. White color indicate peace in India. India is a democratic country. Done. Let us take, these are the different sentences. Now let us see how the ranking system will work. Here, I am taking something. Here I am doing the ranking. So first is the keyword. Let us take keyword, sentence, number of times indexed. Let us take one after another, then we will understand. Keyword, the cat. Here the cat is repeated in sentence 1. Here the cat is repeated in sentence 1. Only one. So it cannot be considered. The words which are taken which are repeated more than one time can be considered. Cat can't take. Sat is not repeated. So let us take wall. Cat. If you want to take, you can take like this also. Cat sentence 1, number of times repeated. Repeated is only 0. Number of times occurred is 1. And next sat again. Sat again in sentence 1. It appeared, and number of times it appeared is only 1. Next one is wall. In wall, it appeared in sentence 1, comma sentence 2. So it appeared totally 2 times. It appeared 2 times. Next one, white. White also appeared in sentence 2, 3. 2 times it is repeated. Next, India. Same, it is also appeared in sentence 3 and in sentence 4. So total it appeared 2 times. So in this example, 2 is getting more. Let us take fifth sentence. India is great. India is great. That's it. So here, India, the word is repeating again in fifth sentence also. So the number of times is repeating is 3. Clear? So if you see here, it is clearly understanding what is the ranking system. Cat sat, it is only 2 times. Wall 2 times. Sorry, cat side 1, wall wide 2, India 3 times. So which, here take one thing as ranking. So which word is indexing more number of times? Which words is indexing more number of times? We can give ranking as 1. And which is next level we can give is rank 2. This rank 2. This rank 2. This rank 1. This is also rank 1. Sorry, rank 3. This is also rank 3. Here, so this is the way how we are going to do the ranking systems of any sentence we are taking. And one more thing is also there for the ranking, that is called as a term frequency. Let us see that also one term frequency. The ranking system can also be term frequency. Term frequency. So what is a term frequency? Means number of times term repeated divided by total number of words. This is a term frequency calculation. Term frequency equal to number of times term repeated by total number of words. This is the formula. See here, what are the total number of words we take in here? For example, if you take in total number of words, this only let's take total number of words like 1, 2, 3, 4, 5. Total number of words are 5, and term number of times the word cat is repeated here in this one. So term frequency for cat is what? Term frequency for cat is what? 1/5. Next, sat is what? Same. 1/5. Here, next, wall, term frequency for wall, 2/5. Term frequency for white, 2/5. Term frequency for India, 3/5. So like this also, by using the term frequencies also, we can calculate the ranking systems. Now come back to the slides. What is the next point? Next point is presentation of results. Next one is presentation of results. Finally, the search results are presented to the user typically in the form of list documents ranked by relevance. The user can then select and view the documents that are most relevant to their query. So once again, come back to the indexing. What are the steps of indexing we see? So let us check again. Indexing. First step to do the indexing is tokenization, where the sentence is divided into different words. We are breaking up the sentence into the different words. Next, normalization. So normalization, again, combination, the stemming and stemming or lemmatization can be considered as a normalization. In my previous class, I clearly explained about the stemming and lemmatization and the differences between stemming and lemmatization. You can see that also. And the stemming or the lemmatization is the procedure where the stem word can be converted into the root word. Next step is stop word removal, where we are removing the stop word like and, is, the. So such kind of why, because in the indexing, the stop words doesn't do any requirements in the search engine. So we are removing the stop word. Next, index creation. Once the content have been tokenized and normalized, as index is created, this index typical consists of data structures. Next, index storage. The index is stored in memory or on disk, depending on the size of data sets and the requirements of retrieval system. For large-scale systems, indexes are often stored on disk and loaded into memory as needed to support each query. So next step is, sixth step is query processing. Seventh is ranking, and eighth is presentation of results. So total 8 steps is taken for indexing. Inverted indexes. Next, inverted indexes. An inverted index is a data structure used in information retrieval system to efficiently retrieve documents or web pages containing a specific term or set of terms. In an inverted index, the index is organized by terms, words, and each term points to a list of documents or web pages that contains the term. Inverted indexes are widely used in search engines, database systems, and other applications where efficient text search is required. They are especially useful for large collection of documents where searching through all the documents would be prohibitively slow. As inverted index is an index data structures sorting a mapping from content such as words or numbers to its locations in a document or a set of documents. In simple word, it is a hash map like data structures that directs you from a word to a document or a web page. Inverted index example. See, we are taking document 1. Like here we are having one sentence. The big brown fox jumped over the lazy dog. Document 2. The lazy dog slept in the sun. To create an inverted index for these documents, we first tokenize the documents into terms as follows. See, again, for indexing, the first step we are using is tokenization, where the sentence is divided into the words. See, the first document, we are dividing the sentence into the words like the quick brown fox jumped over the lazy dog. Document 2. The lazy dog slept in the sun. So again we are doing the tokenization. The lazy dog slept in the sun. The lazy dog slept in the sun. We are dividing the terms. Now, create an index of the term where each term points to the list of the document that shows as follows. See here, it is there in document 1, document 2, quick only in document 1, brown in document 1, fox again in document 1, jump document 1, over document 1, lazy document 1 and document 2, dog document 1 and document 2, slept document 2, in document 2, and sun document 2. So this is the example for inverted Indices, like where we are finding the common words which are repeating in different documents. Search for documents containing a particular term or set of terms. The search engine queries the inverted index for those terms and retrieves the list of documents associated with each term. The search engine can then use this information to rank the documents based on relevance to the query and present them to the users in order importance. See here, with this we can also can do the ranking. So here it is having in the two. Lazy dog, it is having in the two, but according to the stop word removal, we don't consider the, so we can't give the ranking for the. And lazy and dog, these are repeating 2 times, so the ranking is 1, first rank for the lazy and dog, and the remaining all got second rank. There are 2 types of inverted indexes. Record level inverted index, word level inverted index. So, record level inverted index. Record level inverted index contains a list of references to documents for each word. Word level inverted index. Word level inverted index additionally contain the position of each word within a document. The latter form offers more functionality but needs more processing power and space to be created. Steps to build an inverted index. First, fetch the document. So removing of stop words. Stop words, again, we have to remove the stop words like I, the, be, is, and this all are the stop words where they doesn't build any structure for the query processing. So stop words, if we remove the stop words, then identification of keywords can be done easily. Stemming of root words. Whenever we want to search for cat, want to search for cat, want to see a document that has information about it. But the word present in the document is called cats or catty instead of cat. To relate both words, we will chop some part of every word, read so that could get the root word. There are standard tools for performing like this. Porter stemmer is the best one and the default one, which in English language, Porter stemmer is the default stemming procedure. So in my previous class, in my previous lectures, I clearly explained about the stemming and lemmatization. There we can catch up with this stemming procedure clearly. So the stemming means converting the stemmed word to its root word. If you see here, the stemmed words are cats, or cat is a stemmed word, and it is converting to the cat word. The stemming can be done because for the easy search. Next step is record document IDs. If the word is already present, add a reference of the document to index, else creates a new entry. Add additional information like the frequency of the word, location of the words, etc. Index components and index life cycle. And index consists of several key components. Dictionary, that is lexicon, a list of unique terms extracted from the documents. Posting list, a list of document IDs where each terms appear along with additional metadata. Example, frequency, position. Document identifier, unique identifier assigned to each document. Term frequency, number of times a term appear in a document. Inverse document frequency, a measure of how rare a term is across document. Index life cycle. The life cycle of an index includes the following phases: index creation, parsing documents, tokenization text, and creating an inverted index. Index storage. The index is stored in a structured format. Index optimization. Compression techniques are applied to reduce size and increase speed. Index updates. As new documents are added, removed or modified. Index deletion. When documents become obsolete, entries are removed or marked as delete. Interleaving dictionary and posting list. Dictionary structure. The dictionary maintains a sorted list of unique terms and serves as an entry point to the posting list. Posting list structure. Each term in the dictionary points to its corresponding posting list, which contain document IDs, term frequency, and posting information. Interleaving for efficiency. Instead of storing the dictionary and posting list separately, interleaving techniques can be used to improve retrieval speed. Block-based storage. The dictionary and posting links are divided into blocks, allowing faster retrieval of terms and their corresponding postings. Front coding. Common prefixes among terms are stored once to reduce space. Skip pointers. This allows jumping over sections of the posting list, speeding up search operations. Document parsing. Text is extracted from documents. Tokenization. The text is split into individual terms. Normalization. Terms are converted to lowercase and stemming lemmatization is applied. Stop word removal. Common words are removed. Inverted index creation. A dictionary of unique terms and their posting list is built. Compression. The index is optimized for storage and retrieval. This is some explanation regarding the indexing. And now let us move to the next topic. Interleaving. Interleaving is a method used to compare the effectiveness of two ranking algorithms in an AR system. Like search engines, instead of running separate tests for each algorithm and hoping users behave the same way, interleaving mixes the ranked results from both algorithms into a single list. Users interacted with this combined list and their preferences reveal which algorithm performs better. It's efficient and reduces bias from separate testing conditions. The idea: alternate results from two ranked lists fairly, then measure user clicks to judge quality. We can see the example here. What is the interleaving? Image 2 search algorithms A and B rank a document from the query. So here we are doing again algorithm A. What are the words we are having in the document 1 and in the document 2? Can be just now we discussed, and again the same thing is repeating. From document 1, cat, document 2, cat, food, cat toys, care. Again, cat is repeating in document 2, cat toys, document 4, cat health. So like that, we are using the interleaving process. So it is jumping from document, second C here, from A document 1, from B document 2, because cat toys in document 2, in the document 2, cat toys is there. So cat food is document 1, cat is document 2, dog is document 2. Like that we can take. Dictionary and posting list. In IR, the inverted index is the backbone of fast search. It splits into two parts: dictionary, a sorted list of all unique terms in the document collection, like a lookup table. Posting list, for each terms, a list of document where it appears, often with extra information like frequency or position. Dictionary, think of it as a words index in a book, tells you where to look. Posting list, the page number for each word, showing which document contain it and how often. See the example. Here clearly we are having the example. See creation of posting links. Consider a tiny collection: document 1, cat food; document 2, cat toys; document 3, dog food. Dictionary and posting link. See here, cat appears in document 1 once and document 2 once. Document 1, cat appearing once; document 2, cat appearing once. Next, dog. Take the word dog. So dog appears, where the dog is, appears only in document 3. So dog appears only in document 3, that is also once. Next word is food. First, before this explanation, first we are taking terms and posting links. It will be easy to check. See, at 1, document 1 once, document 2 once. Dog, document 3 once. Food, document 1 once, document 3 once. Toys, document 2 once. So we are taking like this. Then query example, cat and food. Cat and food. So where is the cat? Cat, if you want to search for the cat and food. So cat, where is the cat? It is in the document 1 and document 2. Food, food is in document 1 and document 3. Intersects list, document 1 matches. Document 1, document 2, document 1, document 3. So common thing is where? Document 1. So the query searches we find where? In the document 1 as cat and food. So this is called as interleaving. Dictionary and posting in interleaving. Next, index construction. Index construction is a process of building the inverted index. It is a dictionary plus posting list from a raw document collection. It is a critical step in making such fast, but it can be resource intensive for large data sets. The process often involves tokenization, breaks documents into modes, normalization, standardized terms, building postings, map each term to document and count frequency, sorting and merging, organize the dictionary alphabetically, and store postings efficiently. So this is some explanation regarding the interleaving. Let's move to the one of the important topic, that is query processing. Let's move to the important topic, that is query processing. Query processing for ranked retrieval. Query process in ranked retrieval refers to the process of retrieving and ranking documents based on their relevance to a given query. Unlike Boolean retrieval, which provides exact matches, ranked retrieval assigns a score to each document and ranks them accordingly. Steps in query processing for ranked retrieval. Query representation and pre-processing, tokenization, breaking the query into meaningful words, stop word removal again, stemming lemmatization again, and query expansion. So here the new thing we are going to see is only query expansion, the remaining tokenization, stop word removal, stemming lemmatization, everything completed in previous classes. Query expansion, adding synonyms or related terms to improve retrieval. Document representation. Each document in the corpus is represented as a vector in a multidimensional space. Features include term frequency, inverse document frequency, and other statistical measures. Scoring and ranking: each document is assigned a relevant score based on a ranking function. Here we are having something like TF IDF term frequency, inverse document frequency, BM25 best matching 25, vector space modeling, cosine similarity, term frequency, inverse document frequency. Here, let us take one example. Given document, document 1, data mining discovers patterns in data. Document 2, machine learning improves data mining techniques. Document 3, deep learning is useful for pattern recognition. These are the sentences. Now let's do the term frequency, inverse document frequency. Step 1, that is pre-processing. Here, convert all text to lowercase. Next, tokenization and remove stop words. Next, remove resulting word. First, tokenization of all the sentences. See, again I'm telling tokenization means dividing the sentence into the words. So here we did the tokenization. Next, term frequency, calculating here I said you the term frequency. See, here I given explain clearly regarding the term frequency. The same it is repeating. See, term frequency equal to number of times terms appears in the document by total number of terms in document. Done. So here we are having the terms like data, mining, learning, pattern, recognition. See, document 1, data, so total number of words are 5. So the term data is repeated 2 times. So the term frequency is 2 by 5. Mining is repeated only 1 time. So 1 by 5, 0.2. Learning, it is not repeating, so 0. Pattern, it is repeating 1. So 1 by 5, that equal to 0.2. Recognition is 0. So the term frequency is 0. Same in the document 2. Let us check the term frequency. Data is repeating 1 time, 1 by 6. Like that, we are calculating the term frequencies for all the documents, document 1, document 2, and document 3. Compute inverse document frequency, IDF, compute inverse document frequency, IDF. Just now we seen the term frequency. Now let us see the inverse document frequency, IDF. IDF is calculated as log of total number of documents by number of documents containing the term. It is somewhat reverse, total number of documents by number of documents containing the terms. See, data, document frequency it is appeared in 2 times. So 2, IDF equal to log of 3 by DF. So 3 is what? Total number of documents are 3. By DF, it is how many times it is appearing in 2 documents? It is appearing, so 3 by 2. The value is 0.176. This is calculation of IDF. Next, compute TF IDF score. So TF IDF equal to TF into IDF. Now we've seen separately what is a TF, separately what is a IDF. Now let us calculate TF IDF, that equal to TF into IDF. See, the term data, TF IDF for document 1, that is a value which we got 0.4. See here. See, data what we got 0.4 in TF. In IDF what we got 0.176. The term data. So what it is 0.4 into 0.176, that equal to 0.070. In document 1, same we are going to calculate in document 2. Document 2, the data value is what? 0.67, 0.167. In IDF, in TF term frequency, it is 0.167. In IDF, it is 0.176. It is what? 0.167 into 0.176. Like that, we are going to calculate all terms frequency from all different documents. The highest TF-IDF score for document 3 is for what recognition? That is 0.095. So what recognition term frequency we got is what? 0.095. The word data and mining, because it appears in only one document. The word data and mining have relatively lower TF-IDF score since they appear in multiple documents. So words with higher IDF values, less frequency in the corpus are more important for distinguish a document. Next one, BM25, best matching 25. BM25 is an improved ranking algorithm used in search engines and information retrieval. It refines TF-IDF by considering document length and term saturation. BM25 works simple step, term frequency, again calculating the term frequency, more occurrence of a word in document increase relevance, but not infinitely. Uses as saturation factors to limit the impact of very frequency words. Document length normalization, longer documents are adjusted so they don't get unfairly high scores. Shorter documents with the same term frequency are given higher relevance. Inverse document frequency consideration, common words across all documents get lower weight. Rare words are weighted more. So simple example for BM25, again take 2 documents. Data mining finds useful, again 3 documents we take. Query is what? Data mining is the query. Now first step 1. Count what frequency, again data, document 1, 1, document 2, 0, document 1. Mining, document 1, 1, document 2, 1, document 3, 0. We counted the term frequency. Now compute IDF, inverse document frequency. I hope you remember the formula, log minus DF plus, and here for BM25, here it is different. The IDF formula is different. Log n minus DF plus 0.5 by DF plus 0.5, where n equal to total documents, DF equal to number of documents containing the term. Data DF document frequency is 2, means in 2 documents it is reflecting. So DF is 2, IDF is, this is the value. Mining DF is 2, means in 2 documents, out of 3 in 2 documents it is reflecting. The IDF value is this. So total BM25 equal to IDF into, this is the formula where K1 equal to 1.5 times term frequency tuning, B equal to 0.75 document length tuning. So this is about BM25. And next one is vector space model. Vector space model or cosine similarity. Vector space model is a technique used in information retrieval and text similarity. It represents documents and queries as vectors in a multiple dimensional space and use cosine similarity to measure how close they are. Cosine similarity measures the angle between 2 documents. Cosine similarity equal to A into B by A into B, where A dot B product of vector A and B. A is magnitude of vector A, magnitude of vector B. This is sum of the cosine similarity. Always depends on angle between the lines, not the length of the lines. So create term frequency by using the cosine formula, creating the term frequency same. So after identifying the term frequency, next here we are converting to vectors. See here in document 1, term frequency is 1111000. That only we are converting to vectors. See 111000, 11000, So converting to vectors. Next, compute cosine similarity. This is the formula how to compute the cosine similarity. So here we are having another example, but already we've seen the example. So this is the simple explanation about the indexing, dictionary and posting, and inverted index. Hope you people are understand. Thank you.